Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Now, this is a new series that we're starting, so I want to bring you all on and introduce you to Buck Woody. And this is Buck Woody. Nope, this is Buck Woody.
And that's Anna Hoffman. Welcome to this very cool new series we've got going, Anna, and we're live. That is awesome. Yeah.
We're live. I want you to remember that, Buck, that we are live. Anything you say, we are live.
Right. We talked about that, and I'll try and remember. Okay. Well, we've got this new cool series called Something Old, Something New. And so I know there's a bunch of things we're going to be doing in this series. I guess people might have questions about what we're up to.
Yeah, I mean, this episode specifically is called Two Data Scientists Walk into a Bar. What are the odds? And I'm not really sure where we're going with this, but I hope it's something interesting. But throughout the show, if you have questions, comments, you want to say something to us, we could even feature it here on the show today. So if you're streaming from Learn TV, that's the easiest way for us to make sure we see your comments. But that being said, wherever you're streaming from, whether it's Twitch, YouTube, Twitter, or somewhere else that we might be streaming to, please head over there to ask your questions, leave us your comments, let us know what you think of this crazy show and how Buck maybe needs to be reminded that this show is live.
That's right, we are live. You keep remembering that.
Yeah, yes, we are live.
Live, right. Everything I say is important. Well, this show is called Something Old, Something New. So very exciting.
Why did we call this show this? I'm still trying to figure it out.
Oh, remember we talked about this. Math is old and machine learning is new. So that's the something old, something new that we talked about.
Oh, so that's the what's old.
Right.
Math.
Right. Exactly. Math is the
someone, just math.
No.
Oh.
So we're here to talk about data science, and as part of that, we're going to be talking mostly about machine learning. And machine learning, Anna, as you know, very, very simple. Basically, you've got the definition here. A computer program is said to learn from experience E with respect to some class of tasks T and performance measures P if its performance in T, as measured by P, improves with E. Very simple. Can you just tell the viewers at home again what we just covered real quick?
Well, you took it away from the screen. But if I were to think about it, you just said a lot of letters. I'm not really sure what that means. I think I'm more of like a visual learner. Can you try again?
Yeah, let's do an example. Let's just do a very quick examples. Machine learning involves data, and basically you just put those datas together in something called a model, and from the model it'll learn. But what do we mean by learn? A computer can learn. How does it work to do that? Well, let's take a quick simple example. We've got some items here that we want to classify. We want to make sure we know what these are. Now, of course, you know what these are, but the machine has no clue. So basically, we develop a model. And this is oversimplified. This is not how the computer really works. We'll be bringing some things into focus as we go. But in general, if it has an open top, if it has a closed bottom, if it holds liquid, if it's hand-sized, then the label is cup. Is it true? Now, these other things, these columns, are basically just called features. This particular data set is labeled. We can show the computer a bunch of these, and it can develop a model. So let's take a look at how this works. Once the computer sees this data with these kinds of things here, we can take a look at basically how it learns to do this. It says, if the closed top is true and the closed bottom or open top is true, closed bottom is true, holds liquid is true, hand-sized is true, and so on, then it's probably a cup. And it's kind of important. All of this has to do with probability. You'll notice that every one of those pictures, except my cat Tina there on the very bottom, she does not have an open top. She definitely does not have a closed bottom. She does not hold liquid at all. She was hand-sized at one point, but she's kind of a chunker, so she's a big cat, big long cat now. So she's definitely not a cup. So now that we've shown the computer things and we've said that's a cup, that's a cup, that's a cup, we've got this model, if you will. We don't need that data anymore. We've got a model, and we can simply show the computer another object and say, what do you think? And it looks at the model and it says, well, it's got an open top, a closed bottom, it holds liquid, it's hand-sized, and so on, just like the other things. So I'm going to guess that that is a cup. I'm pretty sure that's true, and I'm only 90% certain. So that's basically, I've been married for 35 years now, and I'm never certain of anything, but I'm 90% sure that's a cup. That's kind of the way that that works. So Anna, that's the short version of what machine learning is. But machine learning really is just kind of the math all the way down. That's all there is to it. It forms the basis of everything we're going to do. We're going to take data. We have to turn that data into math. If you think back about that previous example, we had, closed top equals true and so on. The computer has no clue what the word closed top is, or even what the word true is. We have to turn that into numbers. We have to figure out how to turn it into numbers. The true and false is easy, right? We can do a 0 and a 1 for that. That's easy peasy to do. But the words are a little harder. So we might say, what color is it? Blue, red, green, yellow, and so on. Machine learning can't handle those kinds of things. So basically it flips things around, does kind of a pivot table, if you will, and it makes it into something we call one-hot encoding. I've been called one-hot encoding from time to time, not recently or anything, but anyway, I've been called that before. And basically what that means is I just flip the data around into a pivot table and I say red, false, or 0, blue, 1 or true, yellow, 0, and so on. Now the computer can deal with math. And there's a lot of math we're going to be covering, Anna, so just memorize all this stuff. For machine learning and AI, we typically use 3 big branches. Now there's more. This isn't all the math we're going to use. We're going to use a lot more information theory and all kinds of things throughout this series. But these are the 3 bigs we might want to think about. We use statistics to reduce uncertainty, to do predictions and to reduce uncertainty about those predictions. We use linear algebra, which is the study of vectors and matrices. And then we use calculus to determine a gradient to optimize functions. Now you've got all that memorized, right? Are you like checking your phone? What are you doing?
Oh, sorry. What were you saying?
Really?
Well, but I mean, this is just a lot of math. Like, do you think everyone that's watching and anyone who tries to do data science has to know all this math?
Well, I mean, you don't have to know the math, but I wanted to show you a cool thing we put together, Anna. We've put together a site, and it's aka.ms, and it's something old, something new. And not only have we explained everything we're talking about, and you can see all the episodes, but we actually have links here to everything we're talking about. So you don't have to memorize all this. It's just something you can find. Here we go, something old, something new right there. Okay, let me answer your question. Do we have to learn the math to all these things? And the answer is no. We don't have to learn the math at all. You don't have to know how to work on a car to drive a car. But it's nice to know the background of things. I doubt in an hour we're going to make you linear algebra specialists or calculus specialists. If you didn't pay attention in high school, you're probably not going to catch up here. But the general idea is this, Anna. It's just about turning things into light switches. Whenever we see a computer monitor, it's really just zeros and ones cutting off and on that make something that we interpret. That's a lot like what machine learning is doing. It's not a human brain. It's simply cutting on lights on a screen that look like words for us, and it's doing that with math. Now, again, as I mentioned, this math goes way back. We look at things like Bayes' theorems, which we'll use a lot, goes back to the 1700s. Regression analysis goes back to the 1800s. Neural networks were like back in the 50s, 1950s. And some of the math goes back to like the method of exhaustion. That's an apt term. That's calculus. Some of those ideas go all the way back to 400 BC and the Greeks.
So what was it like when you were there, when they were discovering all this stuff?
Well, the early days, we did a lot of this kind of math. We didn't have zeros or anything at the time, but we eventually came up with those. So let's take a look at some of these branches here a little bit. Let's take a look, first of all, at statistics. As Yogi Berra once said, predictions are hard, especially about the future. Statistics, the word, is from Statisticum Collegium, which is the Council of State, and it basically had to do with counting people to tax them, and nothing's changed, right? They say that nothing's certain except death and taxes, but at least it doesn't get worse every time Congress meets. But basically, there are different branches of statistics. One is just the word statistics, which just means the numbers themselves. That's one branch, and we'll use some of that. Another is called descriptive statistics, which explains things like how distributed are these things and so on. But the one we're kind of interested in is inferential or predictive statistics, things that can say, I've seen some stuff in the past, and I can make some guesses about the future based on what I've seen. So we'll see a lot of that. The Greeks, as I mentioned, used this stuff to even build siege ladders back in the day. So this is the descriptive, inferential, and predictive statistics. And we've got some examples we'll be using a lot here. One of them is the word probability, which obviously we've seen a lot of. And then we're going to be getting into Bayesian, causal, and parametric inference, among others. We're going to take a look at linear and logistic regression and how that's used. Some of the classification methodologies. I think you've got some ideas to show us some things there, how to simulate things and so on. Much, much more. Once again, out on the Something Old, Something New site, we've got lots of resources for what you need to focus on for the maths. Now,
how did you learn Latin? Were you there?
Oh, they taught it in school at the time. I mean,
in school.
We sat with a guy, and it wasn't really school just yet. Kind of, that's what we had in our textbooks. I mean, what are you going to do? So the next one we're going to take a look at is algebra, and algebra is almost as old as me. It's from Arabic, the word algebra. It actually has to do with resetting a bone or joining broken parts. That's some of the word that it has to do with there. The deal is this. It has to do with working with symbols, because when we begin to do some of these algorithms that you and I are going to show, we're going to replace some of the numbers that are in there with letters, unfortunately. And sometimes those letters go even further. Now, there's quite a bit we're going to learn inside algebra. So we're going to focus kind of on linear algebra, which is a particular branch within algebra. And we're going to focus a lot on matrices and matrix math. In fact, maybe I'll have you do some of that on the board. You're a smart cookie. You went to college and all that stuff. Maybe I'll have you do a little quick demo for us. You have a whiteboard handy?
Yeah, and maybe I remember how to do matrix multiplication. We'll find out.
Your little phone thing that you kids look at all the time. Maybe you could look at that and see what's going on there. We're also going to take a look at how to find relevant data, because all data isn't useful. So we're going to look at principal component analysis, data conversion with our favorite one-hot encoding. And now you'll always think of me when you think about one-hot encoding. You'll never.
I hope not.
Yeah. You'll never be able to get that out of your head. We're going to create the simplest models we can with regularization. The relationships between variables becomes very important. Linear algebra to show that regression we talked about, super important. We're going to do latent semantic analysis with language processing. We're going to use some distance recommendations. This is kind of interesting. People who liked this movie also liked this movie. People who bought this book like this book. Remember in school when they told you all these formulas and you said to the teacher, we'll never use this? Well, you're going to use it. And then, of course, the matrices with more than one dimension. These are called tensors, and you've probably heard of libraries like TensorFlow and so on. And we're going to be showing some of that as well. So all kinds of fun things we're going to do in algebra. And then one of our most difficult is calculus. Machine learning uses calculus, especially around optimization. Now, you know, calculus, by the way, comes from the word that has to do with breaking things down. And my friend Isaac Newton, he was hilarious. He just said to himself one day, looked at the moon and how it was orbiting, and he said, I wonder how that works, right? And he just invented a math to explain a question he had. He was just an uber nerd. I mean, he didn't go to parties. He never had like a girlfriend. He was like this weird dude.
Focus. Remember, we talked about this. We're live, right?
We're live. Sorry. Okay, so what we're going to do is we're going to focus a little bit on a bunch of things. We're going to talk about those features and labels. Calculus helps us kind of get started with that. We're going to take a look at functions of variables, derivatives, and gradients. Remember those? Those were your favorite, right? When you were getting your master's in data science, which was your favorite of these maths? Algebra, calculus, stats, something else?
Oh, you know, they're all a fun and a half until you actually have to get it to run performantly.
Okay. And which one did you have the most trouble with?
You know, sometimes things around like matrix multiplication, that was kind of tricky for me until, you know, I figured out how to do it in Python, and then it was much easier.
Yeah, isn't there a program that does this? Do we really
Exactly.
just call somebody? I mean, don't we just? All right. So one of the things that's probably one of your favorites and really trips up a lot of people are limits and derivatives. These are of special interest. And
I love that movie.
What?
In Mean Girls.
What's a Mean Girls? That's like every girl in high school to me. What is that?
It was a movie, and you know they say the limit does not exist, and so yeah, I like limits.
Okay. Well, all right then. Limits allow us to work out the answer for things we can't measure directly, and there's a lot of data that's like that. We can't measure everyone in a country or in the world or something, but we can estimate things and we can get close to what we need with limits. Derivatives, among other things, they do a whole lot of stuff. They help us fine tune a prediction. And all of these things are basically about getting as close as you can to the answer while eliminating as many variables and non-predictability and errors as we possibly can. We're just trying to get to the bottom of this thing. You know, one of my favorite things here that we're going to be talking about is Markov chains. I just absolutely love Markov chains. They're just amazing. So Markov chains are this cool math. Let me grab something here. This is so much fun. Let me hear it. Here we go. You know, I like the game Monopoly. There was a lot of fun here. And there's actually a Markov chain in Monopoly. What you do is basically in Monopoly is you go around a board, a game board, and as you're going around the board, you land on squares, and the squares can either cost you money or they can do all kinds of things. But they can also send you to jail. And so as you roll these dice, turns out there's a probability that you'll land on a certain property inside Monopoly. Based on that probability, you can also find out what the odds are that you'll go to another square based on the square you're on only. So stick with me here. So it's not that I started at go. Everybody starts at go, but then you begin to move around. And now let's say I'm on Connecticut Avenue or something, and I want to know what are my odds of going to a particular square from here. It doesn't really matter how you got there. It matters where you'll go after that. However, of course, you had to get there to begin with. And so you create this thing, and here's one here, that's basically a prediction matrix, and then you can make a transition matrix. And this transition matrix will tell you where you'll go next. And I just find it's just so endlessly fascinating about how Markov chains work. And it's just, I just find this stuff just fascinating. So in this series, Anna, we're going to be covering in the first few minutes, like we have been doing, a bunch of the maths, and we'll dive in. We've covered all the maths this morning, but we're actually going to cover a specific math in each episode as it supports a machine learning concept. So why don't you do this? Why don't you take the math I just gave you, and let's just jump over and let's have you take over and show us how to use it. So just, you're in charge now. You show us how to use all that math.
Oh, wow. Well, okay. Well, we'll see how this goes. You know, like I said, my matrix multiplication by hand is not necessarily the best, but we can give it a shot. You know, before we get into that though, Buck, I really think part of this is understanding the question. You know, I think maybe we're getting a little ahead of ourselves. We're looking at all this math without thinking about, you know, what is the question? What are we trying to do? And if we knew the answer, what would we do with that? Because I think that's a huge, important part of going and doing machine learning. For example, you know, we can go predict where you're going to land in Monopoly, but at what purpose? You know, I'm just going to throw the board up and give up after 3 hours anyways, because I spent all my money on the cheap properties. I don't know what your strategy is. Yeah,
my strategy as in life is to stay out of jail.
Yeah, and how does that typically go for you, Buck?
That's all I'm trying to. So you're saying then that we should focus on why we're doing the math before we actually just dive in and do it? Is that your idea?
Yeah, I think you might have a little more success, you know, figuring out what you're trying to do and you know, understanding the background. So here what you're seeing, it's just a screenshot from a GitHub repo, which I'll share with you in just a few slides. It's actually going to help you with all this. It's basically going to do all the work. So, you know, you don't need the math. Well, you need some of it. But
I just spent 30 minutes on the math, and you're telling me really?
Well, let's see what we come up with. Maybe Buck, we can meet somewhere in the middle and drink some coffee.
I will hold my criticism.
Wonderful. So, you know, when we think about machine learning, and once we've understood the project charter and the background, the next thing you might consider thinking about is the type of machine learning that is going to be applicable to your type of problem. So there's two main kind of classes of machine learning, or categories of machine learning, and it's really based on the data that you have and the information that you're trying to gain. So the first type is supervised learning, and Buck showed us a wonderful example. You know, he had to build a program to understand when he was looking at something, if it was his cat Tina or not, or if it was a cup. And that's something called supervised learning. And what that basically means is you're able to train a model with the answers, right? So you're able to give it some data and say, hey, this is a cat, this is a cat, this is Tina, my cat. I mean, this is a cup, this is a cup, this is Tina, my cat. And then, you know, you're able to tell the answer. So if it gets something wrong, it can go back and say, oh, well, that wasn't right, let me think again. And it actually will learn over time based on your examples what the right answer should be. So that's supervised.
The idea there with this supervised, then, if I hear you right, is it's kind of like how we learn. We went to school, the teacher said, here's a math problem, here's the answer, here's the math problem, here's the answer, here's the math problem, here's the answer. And by seeing what's true a lot, we developed a model in our head to say, when she showed us a new formula we had never seen, a new problem, we were able to say, okay, I know the process to solve that. Is this the answer? That's an example of supervised learning, is that right?
Exactly, and I actually think that's a really great example. Now, the other type of machine learning is unsupervised, and this is a little bit different, and you might not think of this as traditional, but you know, this is a really huge part of machine learning, especially in this day and age, where we have like recommendation engines. Now, what an unsupervised learning model is going to do is not have any answers. And so you're just gonna basically throw a ton of data at it and try to identify either trends or groups or something called clusters. You know, you might be familiar when you go to, you know, Amazon and you're putting everything in your cart like I am. They do this really handy thing where they figure out what else I want to buy. So they put this recommendations, and using that is a form of unsupervised learning. Now, this can get very complicated when we talk about recommendation. Maybe you might even use a blend of supervised and unsupervised, but at its large, unsupervised learning is really where there's no set answer. There's no teacher saying, hey, this is the answer, hey, this is the answer, and Buck to learn, however many years ago that was. You know, you just are trying to gain insights from the data that you have.
The clustering, you mentioned the word clustering there, like grouping things together, just saying, I want so many groups and grouping things together. That's really traumatic for me.
Why is that, Buck? Why is
But
that
in
traumatic?
school, they would line you up and everybody would pick from the teams, I
Ah,
want so and so and I want so and so. Um, that just, oh my gosh, that just,
ah,
always the last one. And I seem to cluster around the, let's just say more ample or heavier people. And so it just gives me a lot of flashbacks. And I think we forgot one kind of learning in here. We got supervised and unsupervised, but I have a Roomba at home. Tell me more about Roomba. I love Roomba. By the way, Roomba and Tina are my only office mates now that we're quarantined. And so I've named Roomba. His name is John, and John and Tina are my only friends. But they avoid me. The Roomba avoids me. Comes up.
oh.
Now, how is it doing that? What is that called?
I mean, I think that's by design, right? It's learning that you're in the way, so it goes a different way.
And that's like reinforcement learning, right? That's the third one.
Yes, exactly. And this is how you also might train your dog with something like reinforcement learning, or your friend John, whether he's a person or a Roomba. I'll respect that.
And that's the way Marjorie trains me as well.
Your wife, yeah.
Yeah, she explains reinforcement. She uses that word a lot. She uses that.
Ah,
Yeah, it's kind of.
well.
Well, anyway, I digress. Please continue.
We have some questions in and some comments. So I just want to take a moment before we go any deeper into this topic and maybe get off the rails talking about how you learn at home. One thing I want to highlight is that Rhythm Guy Pratt C. I'm probably saying that wrong, but he said this has been informative. So despite all these jokes, well, our attempts at jokes, and your length of working and that sort of thing, people are thinking this is informative, so that's great. We also have some comments from Stephen Simon from C# Corner, who we're doing an event with actually next week at the C# virtual conference. Definitely check that out for SQL Server. He says, OMG, my two favorite people together on a show. And he said, don't forget to mention reinforcement.
There you go. See, that's my point right there. It looks like
he must have a Roomba.
I think so. Stephen says, I'm curious why we don't mention batch learning and online learning. Stephen, we'll be talking about a lot more things as we go through, and we'll be showing examples of those as we go through. Unfortunately, we are limited by time, so you're going to have to stick with us all 12 months to learn all the different things. We're going to cover everything, even language. Anna, when I was younger, there was only 25 letters in the alphabet. Did you know that?
What?
Yeah, no one knew why.
Sorry. Oh my gosh.
I'm sorry. It's a dad joke. I have to do them. It's a thing. It's a reinforcement.
Okay.
All right, we should move on.
All right, yeah, let's move on. Let's see. So we talked about supervised and unsupervised learning. So let's kind of, as you might hear someone here say, double click on that. So I want to double click on that and look at some of the algorithm families you might choose within supervised or unsupervised learning. So again, like I mentioned before, we talked about supervised is more of like where you have the answers. So this is like labeled data, and then later you show it unlabeled data, hoping it produces that label. Now the other type, what's that?
I like this. This is really nice. Classification, how much, how many, is it odd? Hey, I'm putting that all the time. Reinforcement, clustering, and recommender. I like it.
Yeah, so these are the different families when you think about, oh, okay, I'm going after this question, right? Because remember, I mentioned, it's important to have a question up front. And then you can try to figure out where this question might lie, whether it's which category, which like you said would lead towards classification, how much or how many. So if you're trying to predict some sort of number, you might use regression. There's different types of regression. You might also be predicting whether or not something will happen, and you can use regression for that. The other example is anomaly, and this is not just to identify buck in a crowd. We might see this with financial data where they're looking for fraudulent transactions or logins, or, the list goes on and on. I'm sure there are lots of examples for this. And then there's reinforcement learning, which we mentioned, and this is how Buck is trained at home. This is also how I train my dog Moose, who might make an appearance at some point. And then we talked about unsupervised learning and kind of talked about clustering and recommenders or recommendation models, like, people who bought this also seem to buy this, that sort of thing.
Mm-hmm. Very cool. Very cool.
Now, it gets more complicated than this, because once you get into here, you have lots of different choices to make. Mm-hmm. So, we worked, this was years back. Buck and I can't believe we've been working together for years, but years ago, we were part of a team who created this. And, this isn't overwhelming at all. But generally, it's actually going to be really, really helpful because, right, and I like the straightforwardness of it, right? We're saying from the beginning, what do you want to do? Okay. And now, depending on what you want to do, we're trying to make this easier for you. They've iterated with this over time. Maybe you want to generate recommendations. So you can see there are some good recommenders there, and tells you a little bit more about what type of answer you're going to get. And I think that part's important because we said you have to know your question up front. So understanding which answer. And then, if you pick something that's not recommenders, like you want to predict values, for example, we're going to list some common uses. So you'll see things like neural network regression in there. You'll see push on. Can't ever pronounce that word. I really struggle with that one. Poisson. How do you say that, Buck?
Poisson.
Poisson. Yeah. I know you might have known him, or
yes.
Yeah. So there's lots of things here to help you. And as Buck mentioned, our resource before, I already put a link there for this so you can see it. It's also just aka.ms/ML cheat sheet. So even if you're not using Azure Machine Learning, I think this is still really useful when you're getting started to try to figure out, okay, what family of algorithms should I be looking at? And what question am I trying to answer? And am I going to get there with what I'm doing?
So you've given us so far a sort of a process which starts with defining the question, and then you've given us a bit of a procedure here on how to pick the algorithms we want to use. So you've gone a long way towards getting us started. Even if we don't have to learn all the math, it's a great idea to have that background. Once we have all these things into place, what's sort of next, Anna?
Yeah, that's a great question. I want to mention the team data science process. So I mentioned earlier, I had a screenshot from a GitHub, and this is really what's going to take us through that process. And if I just flip over to that, let's see. Oops, not there. Not there yet.
Don't close it though. There we go.
All right, there we go. So here, what you're going to see is the team data science process documentation. Now, this is actually considered a Microsoft product, believe it or not, this process, because we think it's so important to data science workflows. And a few key things here. If you're familiar with the CRISP DM method, which is around for a while, Buck probably wrote part of it. But this was really around data mining and kind of a process around doing data mining, data engineering, data investigation. And over time, words we use have changed, and also the process has changed. And what we set out to do when they created this product, the team data science process, is really stress the importance that, hey, this isn't just a data scientist off in a cube. I mean, honestly, a lot of times I think the data scientist has the easiest job once the data is clean. It's the data engineer that's got to figure out how to get this data clean, how to get the right data. But this is a really interesting process. Definitely recommend using it. It walks through the roles different people play and also each of the steps. So whether it's business understanding, getting the data and actually understanding the data and, reiterating on what that question is you're trying to answer. And then you go into modeling and deploying your models. And then again, looping back through, iterating back through. It's a very iterative process.
So
Maybe
it
you'll
looks like you even got a project. What is that, project planning? Can you click on that? What is that?
Yeah. So even if you wanted to go through a project, there's actually a Microsoft project template. So what this means is you can actually just go download this template, and it's going to help you actually design how your projects are going to work with data science. And so,
project though, I mean, scroll back up to the top. That's kind of arrogant for you to assume everybody has Microsoft Project, even though they should, because it's one of the best project planning softwares out there. Scroll back up to the very top for me there. Oh, it looks like there's an Excel template as well.
Oh, yes. Everyone wants something Excel. So,
right? Everybody uses Excel. So basically, you're saying that project plan takes that whole team data science process and walks through every single part, has everybody's job in it. So we're basically doing your job for you.
Yeah, we're basically doing your job for you. I guess that's the way you could say it. I mean, yeah. So this is the project template. So you can use this. There's also a GitHub repository, so you can use the GitHub repository to get other stuff. Even when you get into things like the modeling phase, what you're going to see is you're going to see lots more information. So we're going to tell you a little bit more about the life cycle. So this is that part I was mentioning where it's very iterative. So, you could, once you start, you could kind of go anywhere. You could go into data acquisition understanding. Then maybe you understand the data and say, hey, you know what? I want to ask a different question, actually. So you can go back to business understanding. Then you might deploy your model. But then, as you get new data in, you want to make sure you're keeping your model up to date. So you might go through a retraining exercise and a redeployment exercise. And you might do different things while you're modeling. You might explore feature engineering. So basically figuring out which features are going to help in predicting the label.
Are you saying that there's a process we could use to figure out which features, which is just those columns, are most useful?
Yeah, exactly.
So we can do math to find out which math we need to do.
Yes, but there are also lots of tools. So even though you're doing lots of math behind the scenes, there are lots of tools. There are even some full worked out examples. So if you're using SQL, HG Insight, iSpark.
Oh, that's neat as all get out. Anna, we've got some questions here. Let me pop a couple of these in. Simon says, would you say y equals mx plus c or mx plus b, the hello world for data science?
Yeah, I mean, I could take it. I mean, this is for those of you that aren't familiar, the y equals mx plus c, or usually I think it's plus b, but whatever letter goes at the end, maybe it's not a y because Buck doesn't even know about y.
Well, yeah, because there's USB-C and I mean USB, regular, and now there's USB-C. That's why it's y equals. I don't know why you did that. Anyway, okay. I agree. Yeah, I think it is absolutely, because that's the slope of the line, isn't it, Anna?
Yeah, so that's the equation for a straight line, and that's kind of how you might figure out a slope. And I guess at the highest level, this is going to be linear regression.
There you go.
Sure, I think that's a good example, Simon. Okay. The other question comes from Jack Bro. She says, where does Buck do his clothes shopping?
Oh, yeah. It's a long and tortured journey. Anna thinks I get clothes from the Mad Men set. I'm usually in a suit, three-piece suit and tie. So she thinks actually I was part of the Mad Men episodes, but I don't do that. I was called a hipster once, but I'm like, these are just my clothes from when they were actually introduced. So yeah, that's kind of where that comes from. So
no real answer there.
We got all this other stuff. What else do we have, Anna, going on inside the data science world and understanding the machine learning stuff?
Yeah, definitely. If we can bring ourselves back to the topic. Yeah, so we talked about the data science lifecycle and some of the tools. Now let me just switch back here. You see it here again.
Very useful resource. Thanks for showing that. Oh,
Yeah.
so we've got a process, we've got a procedure, and now you're saying we've got a platform?
Yes. So this is the very important part because, it's all great and dandy for us to talk about these things, but where are they actually happening and what can we use for them? And by the way, the show is called Data Exposed. People know we work for SQL, so how does it relate to SQL? So yeah, we wanted to circle back here and really, we think that SQL itself, if we shift gears to SQL Server, Azure SQL, really has a platform for you to kind of train and deploy anywhere. So whether it's on-prem, in the cloud, at the edge with something like Azure SQL Edge, some combination. We think we bring a lot to the table in allowing you to kind of deploy anywhere. We can even take in models from other places. Various deployment options offer support for things like Onyx. So if you're creating models using other things and other data sources, you can bring them in very easily. What are some of the places that you use machine learning in, Buck?
So this is perfect to talk about a little bit because, as you mentioned, SQL Server now has a full machine learning engine inside of it, and it can use R, it can use Python, Java. You can write your own. We've open sourced that, so you can write your own. We work well with Azure Machine Learning. We learn in the cloud and so on. But this comes back around to your process you were talking about earlier. Remember I said we collect data and we need to look at it to see if this is useful for us to do our predictions. Well, of course, SQL Server is a fantastic engine because it supports SQL, the language SQL, to do queries of data at scale. And it's very secure. So I'm able to do my data exploration part, and then I'm able to train. What does that mean? Well, that means that whole thing of showing the computer those answers that we talked about in the case of supervised learning, or letting it walk across the data in the case of unsupervised learning. And it does that all on that data, and it can be done right there in that secure environment. So that's data ingestion and exploration, the training portion, and then you create that model. In effect, it's just like an Excel formula that you're saving out. It can create those models, but then it can also do something called scoring or predicting. We would call out to SQL Server and say, here's data you've never seen. Will that customer churn? Will this person buy this? Will the weather be warm tomorrow? And so on. And it will do the prediction and send it back. So all phases of that are there. Not only that, because the data is all in SQL Server and the machine learning model can run as a stored procedure, you could have a query run across millions of rows of data, and then it could query that and give you the responses in yet another table or just back to the screen. That's called batch mode. Or it could be real time to where you're making calls based on the model you have. And as Anna pointed out, you could take that model and ship it to something else, either the cloud or even another provider and so on. So this is a great list and shows that you could train and deploy on-prem, in the cloud, all the way out to edge. Very cool.
Yeah, definitely, Buck. And I just wanted to add in there, one of the really awesome things about SQL Server, and it's now supported in Azure SQL Managed Instance in GA, is this idea of doing in-database machine learning. And we're not going to dive into all the details of what that means, but usually you have these ETL processes, and what in-database machine learning is going to allow us to do is just not have to move data around a ton, especially when we're in that exploration phase, the data understanding phase. It can be really nice to not have to move all the data around and just do in-database machine learning. So that's pretty cool.
Process, platform, procedure. How do I know what to do now? What do I do, Anna?
Yeah, that's a great question. So what do you do now? So we talked about this platform, right? How you can use SQL as your platform as choice if you like, how there are options for you in the cloud, at the edge, really wherever you are, even in Azure Arc, and those types of places in big data clusters, which I know many of you listening today maybe have heard Buck talk about big data clusters. Very fascinating, especially for machine learning. Now, what to use when? Now, when we talk about languages, there's lots of languages to use. Some of the more popular ones are languages like Python or R, or I would say those are my favorites and my go-to. Buck, what are your favorite languages and go-tos?
Well, either hieroglyphics or I go back to Syriac a lot when I need to use that. Sometimes Aramaic. Oh, you meant computer science
languages.
Yeah, pretty much Python and R. Probably R and then Python for me.
R and then Python. Yeah, I think, it's a toss-up on R or Python. What are you doing and what are you comfortable with?
Really?
So this last, yeah, go ahead.
Oh, I was going to say, really, it is. They support the same packages these days almost. It really does depend whether you want a sort of a general purpose programming language like Python or whether you want sort of more of a data-centric programming language like R. The neat thing about SQL, as you mentioned, is I could have models that were done in Python and R and just call those independently. So it's really immaterial.
Yeah, exactly. And like you said, all the packages like scikit-learn, Caret, TensorFlow, PyTorch, Keras, Matplotlib, ggplot. I mean, we could go on. Seaborn, that's a great visualization one. We'll list some of these packages in our resources, but there are lots of packages for you to leverage so that you don't necessarily need to write out all the code for all the math from scratch every time. I think, understanding the math or the old stuff is important, but you don't necessarily need to go back and derive the whole thing.
I'm
every
always
single time.
letting other people do my work. I'm absolutely.
Yes, I'm aware.
Yeah, it's just a thing. So here's the other question. We've got one from someone that says SQL can be done Azure ML Studio and Azure Notebooks too. That's correct. So the Azure machine learning stuff, you can also do the SQL machine learning and so on inside Azure Data Studio, which is based on Visual Studio Code. If you haven't checked out Azure Data Studio, you should definitely do that. Now, Anna, this has all been just absolutely stunningly fascinating. I'm sure we've got millions of viewers on right now, and I'm sure some of them right now would love to know how to sort of make this real. Now, my real example is if you'd like to get struck by lightning. There's a few places in the world where that's really easy to do because of statistics. And one of those is actually near here where I live. It's a place called Orangewood, Florida, and it's the highest. There's only one other place higher in risk to get struck by lightning. And do you know I've been struck by lightning?
Really?
True story. Here in Tampa, in the Tampa area, when I was younger, I got struck by lightning. And it's not something I'd recommend. It wasn't pleasant at all. It burns, it hurts a lot. But I've been struck by lightning. So statistically, you're likely to be struck here by lightning. So if that's something you'd like to do, I don't know if you have a better example of something that might be a little more pleasant than getting struck by lightning. Do you have something where you could show us an example of machine learning that has helped you in your, your day-to-day life?
Yeah, I have, I think, a pretty good example, and I think maybe you can relate to this. So my husband sometimes helps me in the morning. I drink coffee. I drink tea. Now, a big problem that we have is that he doesn't always know which one that I want.
He can't just read your mind and figure out.
I don't know. We've been through it a few times. I just don't understand why he just doesn't know by osmosis or whatever what I want to drink next.
You realize every husband out there right now is trembling in fear.
As they should. You should know what your woman wants or man or whatever wants next. But that being said, you talked about Markov chains earlier. I know we wanted to test my matrix multiplication skills. So we put together, sorry, go ahead.
No, I said, that's great. Let's take a look at it. Are you saying that you used Markov chains or math to help your husband figure out what you want?
Yeah, and this is an ongoing thing, like stop bringing math into it. But, it just seems to work and it makes sense. And,
So you're a total nerd. Is that what you're telling me?
No, not at all. I just have a very important caffeine addiction.
Okay, well, let's see what you got here. I'm with that introduction because I don't know, maybe this could be helpful with Marjorie. Maybe there's some sort of math I could do to figure out how to stay out of trouble.
Okay, so let's try something new.
Okay.
I'm going to show you.
Okay.
We've never done this on the show, so we'll see how it works. Okay, so what I'm going to do is I have a whiteboard over here. Now, can you see my whiteboard?
Yeah, 1, 0, 0.7, 0.3, 0.6, 0.4. What am I looking at?
Exactly. Okay, so what we're looking at here, if we just look at the left side, for example, okay. I created this matrix. So this is a 2x2 matrix. Okay. And in this matrix, I created it to show my husband what I like to drink. So now what I'm going to actually do to make it a little more clear before we get into it is I'm going to hop over to my screen. So what you see over here before we get into it is this table that I created. And this is going to turn in
your notebook in Azure Data Studio.
Oh, yes, it is. Indeed, it is.
Okay, neat.
Yeah, so using Azure Data Studio, which is an awesome tool, they have notebook support, makes it really easy to use, Python kernels, and even things like a SQL kernel. But what I did here is I made this table, you can see, and it's, do I want more coffee or more tea? And so how it works is it takes my current state, so it figures, okay, did you have a coffee or a tea first? And then I'm using this matrix, and this is what Buck mentioned as the transition matrix, I believe. Is that right, Buck?
That's right, that's right, yeah.
So see, I was listening. I was on my phone, but I was listening. Millennials can do both.
Sure you were, yeah.
So what this says is basically, if I've had a cup of coffee, then I'm 70% likely to want another cup of coffee, and 30% likely to want to switch to tea. Now, if I have a cup of tea, then I'm 60% likely to switch back to coffee because I need more caffeine, or 40% likely to have more tea.
Okay.
Make sense?
It does. I'm fascinated that you made a notebook and code and a transition matrix to instruct your husband what to bring you next for something to drink.
It's a very important topic.
I'm still spinning on that, but okay, keep going.
Okay, so now let's go back to here. So let's go back, make sure we can see it.
I see the whiteboard.
All right. We've never done whiteboarding before on Data Exposed Live.
Well, you've never had me on before either.
Yes, and we are live. Let me remind you.
That's right. We're live. Sorry, everybody. Sorry.
Okay, so what we did is we took our table that I showed you and made it a matrix. Very easy. So I have 0.7, 0.3. So if I've had coffee, I'm 70% likely to have coffee again, 30% to switch to tea. If I've had tea, I'm 60% likely to switch switch back to coffee, or 40% likely to have more tea. Follow?
Okay, got it. Yep.
Okay, so let's take a scenario and kind of walk through it, and we'll see how my matrix multiplication goes. So this is my scenario. So this is going to be my initial state or my current state. So I'm going to say my initial state is I just had a cup of coffee. So like you talked about, 1 hot and coding. 1 is for the coffee, and 0 means that I didn't have tea.
I see.
All right. So now we try to do math.
Okay,
so
let's do some math.
Do you know how to do this?
You do it. I want to see you do it.
Okay, so what we're going to do is we're going to do matrix multiplication, and we can do that by using the dot product. So what I'm going to do basically is take this and put it this way and multiply them. So I'm going to do 1 times 0.7 plus 0 times 0.6. That's the dot product.
That's right.
So what I'm going to get here, that's going to give me my first number. So that's not 1.
No.
No, it's not. 1 times 0.7.
You need your
Sorry?
You need your phone.
Yeah, I might need my phone. 1 times 0.7 is 0.7 plus 0 times 0.6,
which is 0.
0. So we just have 0.7. Okay, I can
Good.
I do one math. Okay, so now I can do 1 times 0.3 plus 0 times 0.4, which gives me 0.3. And this is kind of an easy example because what it's saying is if I have a cup of coffee, then I'm 70% likely to have another cup of coffee and 30% likely to have tea.
Very cool. So this is simple. Why does Phil not get the deal? I mean, why doesn't he just understand what you want?
Well, then it gets complicated because maybe I told him I had coffee first, And then, you know, he doesn't know, or I went and got my second cup, so he's not sure what it was. So he needs to figure out, okay, well, what does she want next? So here's where it gets interesting. Can you still see this?
I can.
Okay, so now what we're gonna do is we're gonna do it again. So we have a new current state, and we have the same transition matrix. So this is where the math gets a little, you know, we'll see if I can do it without a calculator. But basically what I'm gonna do is 0.7 times 0.7 plus 0.3 times 0.6. So this is 0.49 plus 0.18, which is 0.57, 0.67. I think that's
Very
right.
good.
Okay, and then for the next column, so again, I'm going to do 0.7 times 0.3 plus 0.3 times 0.4. So that's 0.21 plus 0.12, which is 0.33. So for we have my first cup of coffee. If I had coffee first,
Right.
then my second cup's probability, 70% coffee, 30% tea. And then the third cup would be 67% coffee and 33% tea. So over time, I'm potentially going to want tea more.
I see. Very interesting. Now, show us in our last 5 minutes here, show us the notebook you did for this. 'Cause I'm still bugging out. I'm just weirding out on the fact you made a notebook. You didn't show this before, Phil, did you? Or you don't tell him that he's right or wrong. You just tell him that he's not right. Is that?
Well, you know, he's not a data scientist. So the nice thing is I can export this to a PDF and I can just send it to him and he sees the full report.
I see. I'm assuming you do that on your phone or something, I would assume.
Yeah, well, so
So
let's say I didn't want to do all this math, because after this, if we're talking about the 5th cup of coffee, it could get a little complicated.
I see. So you would send this out in like Instabook or Facebook. What is it called? The thing you send
Yeah,
it
a DM on Instagram, something like that.
out? Okay. All right, got it.
You're close. Insta giggle.
So here we go. Finished a cup of coffee. Good. That's line 4.
Yeah, so this is our initial state, and this is that transition matrix.
Good. Same thing you just showed on the board. And then
exactly.
your multiplication, nicely done.
And Python can just do it. So.
And then just print it. And there it is. That's all he needs, is just this algorithm in his head.
It's all he needs. He just needs to learn this algorithm.
70 and 30. For cup number 3, the probabilities are 67 and so on. And it does the work. Look at that. Well, that's very cool. Markov Chains, super useful and powerful. Math is just awesome. And so is data science.
Math is awesome, and so is data science. And you know what I'm going to challenge you to do, our viewers, if you're interested in this, in our website, aka.ms/SOSN, that stands for something old, something new, there are some exercises. And so I would love for y'all to take a look at these exercises and then either comment and let us know what you come up with, or maybe at the beginning of the next episode, if we can remember, we'll talk about some of those answers.
This is really cool. Oh, this is very cool. We can make them show their work and everything. Now, are you saying this notebook is out there too?
Yes, even the notebook. So you can print this PDF out and give it to your partner. And then you might have to update the transition matrix, because maybe you drink more tea than coffee, but just update your transition matrix and now you have a PDF for your significant other and they can know, based on Markov chains, what you want next.
How cool is that? Well, Anna, this has just been fascinating. It's been fun being here with you. As always, I'm glad you're safe and happy and everybody's doing well. I hope every one of our listeners is doing well. And I just want to give a special thanks, a shout out to Wolfgang Pauli and Jeremy Reynolds, 2 good friends of ours that are data scientists extraordinaire, unbelievable. Of course, the folks at Learn TV and Channel 9, as always. Your show this month or week was produced by Marisa Brasile, Anna Hoffman. There you have Anna Hoffman sitting right in front of you, and Cameron Thomaser, that also is in the background doing tons and tons of work. Well, as we close out here, I want to make sure I invite you to next month's episode of Something Old, Something New on Data Exposed, where we talk about Anna the Explorer.
Wait, what are we talking about in the next episode?